Next, we have the types of sets. First, we have finite and infinite sets, universal set and null set, equal and equivalent sets, joint and disjoint sets, and subsets. We say that a set is finite if it has countable number of elements. If it does not, then that is infinite. So here are examples of finite set. We have one set A is composed of months starting with J. So you have the elements January, June, and July. So there are 3 elements in that set. Next is composed of female presidents of the Philippines. So you have the elements Mrs. Gloria Arroyo and Mrs. Corazon Aquino. So there are 2 elements in that set. Conversely, for infinite set, it has uncountable number of elements. We have set Y composed of stars in the sky. So there are a lot of stars in the sky. So there are an uncountable number of elements. Then you have set Z composed of integers greater than 1. So you have 2, 3, 4, 5, and so on. More likely, the set is an infinite set. Now, can you identify which of these are finite and infinite sets? Okay, very good. Set B, set of whole numbers less than 10, is a finite set, as well as set C. Okay, however, sets A and D are infinite set. Very good. Okay. Next is the set contains all elements being considered in a specified setting is a universal set. It is denoted by that symbol U. Next we have the empty set or the null set. It does not contain any element and it is denoted by these symbols. Okay, as an example, the set U is the set of small letters of the English alphabet, while in empty set you have set W contains all positive integers less than 0. So take note that positive integers are greater than 0. So set W has no elements. Now, can you identify which of these is an example of universal and an example of an empty set? Very good. The set of months in a year is an example of universal set, while the set of odd numbers divisible by 2 is an empty set. Okay, next we have sets with exactly the same elements is called equal sets. We have set R and set S. Set R contains the letters in the word name, while set S contains the letters in the word mean. Notice that in two sets, although the arrangement is different, but the elements are exactly the same. So we can consider these as equal sets. On the other hand, sets with the same number of elements is called equivalent sets. So we have examples, set T and set U. Set T contains the vowels in the English alphabet, while set U contains the first 5 positive integers. So as we can notice, set T has 5 number of elements, and set U also has 5 number of elements. So that is why we'll consider set T and set U as equivalent sets. Two sets are said to be joined if those sets contain at least one common element. So say for example we have sets F and E. So these are examples of joint sets. Okay, set E contains elements 1, 2, 3, 4, and 5, and set F contains elements 1, 3, 5, 7, and 9. Notice that 1, 3 and 5 are common to both sets. In contrary, disjoint sets are sets with no common elements. Okay, say for example, we have sets Y and Z. Okay, set Y consists of elements 1, 3, 5, 7, 9, 11, and 13, while set Z consists of elements 2, 4, 6, 8, 10, 12, and 14. So as you can see, there is no common elements in both sets. Subsets. If every element of set A is also an element of set B, then set A is a subset of set B. That is denoted by, you have that symbol. Set A contains in set B. Okay, say for example, we have these two sets. Set A has elements 5, 10, 15, 20, and set B has elements 5, 10, 15, and 20. That means that set A is a subset of set B, since all of the elements in set A is also found in. Then we have proper subsets. Okay, if A is a subset of B but not equal to B, then A is a proper subset of B, which is denoted by A is a proper subset of B. Then we can represent that one by this Venn diagram. So you can notice this, there are elements of B which are not in A. The example, set A consists of elements Math, English, and Science, while in B you have English, Math, Science, Araling Panlipunan, and Filipino. So there are elements in B which are not in A. That is proper subsets. Okay, so in order to illustrate sets, we have this Venn diagram. So I want you to take a look at this short video. Next, we have operations on sets. Okay, first we have the intersection of sets. If we say intersection of sets, we have the intersection of sets A and B written as A intersection of B. Or take note of that symbol, that's an inverted U, is the set containing the elements that are in both A and B. In short, elements that are common in two sets, two or more sets. Okay, let's have this example. Set A contains elements 1, 3, 5, 7, and 9, while set B contains elements 2, 3, 5, 7, and 11. So, the common elements are 3, 5, and 7. So, the intersection of sets A and B is the set of elements 3, 5, and 7 because these are the common elements of the two sets. Okay, now we may also show and represent the intersection of sets using Venn diagram. So when we are using Venn diagram, the first part that we need to fill in is the intersection part or part in which elements are in common or the overlapping part of the two circles. So since the common elements of sets A and B are 3, 5, 7, then we will place or put the elements 3, 5, 7 on the overlapping part of the circle. Okay, the next thing to do is to identify the elements in A which are not in B. So you have 1 and 9. Then in B also which are not in A, you have 2 and 11. Okay, next we have union of sets. So if we say union of sets, the union of sets A and B written A union B, so take note of that symbol, is the set of all the elements that are in A or in B or in both A and B. So if we say union, meaning all the elements or we are going to combine all the elements of that sets. We have example, set A consists of elements 1, 3, 5, 7 and B consists of elements 1, 2, 3, and 4. So the union of sets A and B is equal to the set of elements 1, 2, 3, 4, 5, and 7. So as you can notice, I only write number 1. So take note that in writing elements in a set, there should never be a repetition. So if we will show it through a Venn diagram, so you have 1 and 3 as the common elements of sets A and B. Then for the remaining elements in A which are not in B, you have 5 and 7. And for the remaining elements in B which are not in A, we have 4 and 2. Okay, next operation is complement of a set. So if we say complement of a set, the complement of a set A, written A, as you can notice, you have apostrophe, okay, that symbol, is the set of elements in the universal set that are not in A. So take note of the word not in A. So that is complement of set A. Okay, example, we have the universal set is the set contains 1, 2, 3, 4, and 5. And then set A, you have elements 2 and 4. Set B contains of elements 2, 3, 4. Then set C, we have 1, 2, 3, 4, and 5. And set D is an empty set. Okay, if we are going to find the complement of A or elements that are not in A, that is 1, 3, and 5. While if we're going to find the complement of B or not in B but it is present in the universal set, we have the set of elements 1 and 5. Next is the complement of set C. So elements which are not in set C but present in the universal set. So it's nothing. It's an empty set. Okay? Okay, next is the complement of set D. So not in set D but present in a universal set, we have the set of elements 1, 2, 3, 4, and 5. So if we are going to illustrate it through a Venn diagram, so we have that Venn diagram for complement of A. Next is for the illustration through a Venn diagram of the complement of set B. And then we have also complement of set C and complement of set D. And that's the end of our discussion about sets. See you on our next session. This has been Teacher Alpha saying, keep safe.